Hi folks, welcome back. Of course, by now MCP has gotten a ton of traction. In fact, it's now the de facto standard for connecting LLMs and agents to APIs and databases. However, there hasn't been a great benchmark to evaluate how well a system works with MCP or how good this tool calling accuracy is that ultimately leads to task success. So this paper we're looking at today that came out just a few days ago proposes a new benchmark. They call it MCPMark, and their distinction compared to other MCP benchmarks out there is that they want to be much more realistic and comprehensive, so true to complex real-world tasks. And in some sense, you can see that these tasks are pretty complex because the highest score is only about 50%. So let's look at what's in this benchmark, how they constructed it, and then how today's best models actually perform on it. So the thing they actually want to tackle is that they want to capture complex multi-step workflows typical of real-world usage. And that's the thing a lot of previous benchmarks missed. So if you look at a lot of previous benchmarks, they had these synthetic kind of tasks or very read-heavy tasks, whereas this benchmark aims to do read and write tasks. And importantly, compared to some of the other benchmarks, the verification of whether a task was achieved successfully or not is purely deterministic. So they have a script to determine whether the task was successful or not. Okay, so the way they set it up is first they pick a set of MCP servers that this benchmark uses or operates over. And they've picked these 5 fairly well-known MCP servers that between them cover a diverse set of tasks. So they have Notion, and this represents a good CRUD API for handling documents and databases. They have the GitHub MCP, and this can let you do source control, versioning, CI/CD issues, all the management stuff for software development. Then you have a very basic file system MCP, which is kind of a very basic one. It lets you read and write files and crawl the file system. You have a PostgreSQL MCP, and this, of course, is to do operations on a relational database. And lastly, you have Playwright, which lets you surf the web and do browser automation. So between these 5 MCPs, you can cover a very broad range of tasks. And so it's a pretty realistic set of MCP servers. And every task in the benchmark is specified in terms of an initial setup. So this defines the state of the world before the task starts executing. So this is your initial database, initial file system, and so on. So this is given as part of the task description. Then, of course, you have the task to be done, which is your initial prompt. This goes into an agent to execute it. This task description is along with the initial state of the world given to the agent or the LLM. And at the very end, like I was saying, they have a script that programmatically verifies whether the task succeeded. So they have a bunch of checks which look for an expected output, if some file was created, if the file contained the right contents, etc. And they know the right answer because they have specified the initial state of the world. Now, it's commendable that they put a fair amount of effort into creating these tasks. Like they say here, it needed 10 experts with very professional backgrounds, CS PhD students, software engineers, AI investors. Each task took 3 to 5 hours of focused expert effort. So this is an interesting trend in AI benchmarks in general. We are way, way past GSM 8K kind of tasks. So even constructing a meaningful benchmark that doesn't get saturated right away takes a lot of effort. And you can see this trend in a video I did a week or so ago on GPT-Val, where each task really took maybe a week or more of effort of very senior experts in a field. And at the end of this process, they came up with 127 tasks, which use these 5 MCP servers. All these tasks are in a GitHub repo that they have made public, so you can go look at all the tasks that they have. This diagram here shows the tools that each MCP server has, and these are the typical tools you'd expect. For example, the GitHub MCP has tools for dealing with issues or creating repositories, getting a pull request, and so on. The file system, MCP, of course, has tools to read and write files, to list directories, all the things you'd expect. Okay, so what are the results on today's cutting edge models? They aren't super promising, or to put it another way, there's a lot of room left for improvement. So the top scoring model was GPT-5 with medium reasoning, which is a little bit surprising that it wasn't GPT-5 with high reasoning. And as you can see that the pass at one rate, so passing with just one attempt, was only about 52%. If you let it make 4 attempts and measured whether any one attempt passed, it goes up to about 68%. But what you really want is some kind of repeatability or reliability. So you can see that in this pass raised to 4 metric, which means you ran it 4 times and all 4 times it succeeded. And that goes all the way down to a third, so only 33%. Grok 4 is in second place. Claude Opus 4.1 is in a somewhat distant third place. And this graph is really interesting because it shows the distribution of success with the number of turns. And you can see that the models that did well, like GPT-5 Medium, they did so with fewer turns. So this is not just a question of throwing more compute or more thinking at the problem. The models that did well did better reasoning and accomplished the task with fewer turns or fewer MCP tool calls. Naturally, this leads to the question of why is the score so low? What breaks? And they did classify failures, and they are breaking it up into 2 buckets, implicit and explicit. And implicit really is the larger bucket because it captures a lot of things and it captures all the cases where failure is not straightforward. This happens when the task completes successfully, but the output is incorrect. And the reason for the output being incorrect could be one of several things or a combination of several things. It could be reasoning, could be planning, not invoking the tool properly, and or some combination of all these things. So the task still goes to completion, but because some step in between was not correct, the final output is still incorrect. On the other hand, if you look at explicit failures, that happens when the flow breaks due to some specific failure, and they categorize these things like context window overflow, or the number of turns being exceeded, or the model just abandons the task where the model says, I can't do this, or malformed tool calls where the tool call is syntactically invalid. So if you look across all these top models, Gemini 2.5, GPT-5 High, you'll see that the biggest chunk of failures, it's 84% here with GPT-5 High. The biggest chunk of failures is implicit failures. So this is a great benchmark because it's actually pointing out areas for future work. So of course, tool calling accuracy and reasoning needs to be better because it's not just about trying out more things with more turns. So this goes back to better reasoning. We also need the models to be more reliable. And what that means is if you see that in the difference between pass at 4 and pass raised to the power of 4 metrics, where you don't just need it to succeed in one of many attempts, you need it to succeed in every attempt. Now, one critique of the setup is that if you look at their GitHub repo, they use their own agent harness. And if you play with systems like the Codex CLI or Claude Code and so on versus other agents, you'll know that the agent harness has a big effect on the effectiveness and success rate of a model. So if you take the same model, say Claude Opus 4.1, you will notice that its performance is very different, say, in the Cursor CLI agent versus the Claude Code CLI agent. And so the harness does matter a lot. And if you look at the harness that they used for all these tasks, it is a fairly simple harness. It uses light LLM, which lets them change the underlying model as a parameter so that they can do this benchmark. But the system prompt here is pretty simple. If you look at some of the system prompts for things like Codex or Claude Code, it is much more detailed. It's not super long. It's still maybe a page or 2 pages, but it's much more detailed and has a lot more information about the tools that the agent is using, particularly about how to use the file system. So you could level the critique that maybe the low success rate seen in this benchmark is because the harness wasn't really pulling out the best performance from the model. At the same time, to be fair to them, they needed a harness that was somewhat generic and could be used with multiple models and wasn't tuned to a specific model. Like, say, for example, the Claude Code harness is tuned for the Claude models, or the Codex harness is tuned for the OpenAI models. All right, so that was a quick look at MCPMark, a new MCP benchmark, which has a bunch of realistic, real-world, multi-step tasks. So I think this is a good new addition to the set of benchmarks to look at. I hope you found that useful. If you like content like this, please like the video, consider subscribing, and I will see you next time.